In a past video, I took a Franklin oscillator, my test bed, with the eBay frequency counter, and I let it sit for a few hours at night, and then I set it for 2.5 megacycles. And then I shut it off overnight, and I showed you a cold start. Now this is going to be a little different. I quickly set this thing for 2.5, and then I turned it off. And I'm going to show you. We're going to go the other way. We're gonna start it where it was set for 250 and see where it drifts. Now, when you look at my frequency counter, it looks like the displays are orange. They're not Nixies, they're LEDs. This is an HP unit. And one of the other things I want to tell you, HP unit's got a crystal in there, and the crystal's not in an oven. So that crystal can drift so many hertz. See, when you get really into an oscillator that doesn't drift, you'll have the crystal in an oscillator, or you'll buy a module that has the oven built into it. You can buy for like $6 a oscillator module, little tiny thing with 4 pins, and it has an oven in it that keeps it warm. As soon as you turn it on, the oven heats up, and it stays good within so many parts per million. But when you want to build a radio, you got to have an oscillator that's variable. And yes, you can buy one of them DS units, and those have a crystal in there that has an oven, and there's a tiny, teeny bit of drift, but you'll never see it because it uses the same oscillator for its frequency counter. So it's like the fox guarding the hen house, but the DDS units are really accurate. The problem with them is they create a lot of noise, and the reason you would want to build an old-fashioned oscillator is just for the fun of it, but it's also the fact that you're going to have less noise. And a Franklin oscillator is a great choice because it has very good stability, and you get more of a tuning range with it than say a Colpitts. That's why I use it. Now I'm going to turn this Collins 51J-1, the model that doesn't exist. I'm going to turn it on, and here we go. We're on. Saw a bit of a glitch, and we'll see how fast this thing drifts out. Okay, the S meter's coming up, going back down. All right, we're at 2.50 megahertz. Look at the amount of drift already. We're up 500 hertz. Well, let's get this off. All right, now we're coming back down. Got to remember this PTO in this radio is the square one. It doesn't have a heater built into it. But now that I'm showing you this, I want to tell you that say even 100 hertz shift, most people can't hear that. If you're into Morse code, you may hear 100. Now this thing's going to go the other way now. So this unit here drifts more than if you were to build the Franklin oscillator. But you got to remember, the Franklin oscillator uses a FET, or 2 FETs. It wasn't invented back when this was made. This was big technology back in those days. So now we're already, well, we're up 200 hertz already. We're already worse than the oh God, the Franklin oscillator. Hope you can read the digits. You know, I didn't exactly go big money on my frequency counter. I tend to be very cheap. Conservative is one word, but I'm cheap. And I get mad a lot of times when I buy something. If you look at the quality, the condition this HP is in, it's pretty sad looking. So we're already past this. So I just wanted to show you that, you know, back in the day when they had an oscillator that was within 500 cycles, that was great. That was incredible. And now as this heats up after an hour, it's going to stay within, so let's just say on a good day with the temperature staying stable in the room, it'll stay within 50 hertz. So if you're into old radios and you don't have the patience, see, when you first turn this thing on, this thing's going to drift. and you might be able to hear it, and it might bother you. And it might bother the guy on the other end, the guy that has to follow you up and down the band, 500 hertz. Yeah, and the new set you turn them right on. It's almost like, let's just make the argument. If you're going to argue an old tube radio versus a modern ham radio, I can argue a modern ham radio versus a cell phone. If you want to go there, I'll say there's no need for ham radios except in emergencies, because a lot of cell phones do go down. Earthquake, a cell phone tower might just go bonkers and it's gone. And then how are you going to charge your cell phone? Now these ham guys, the ones that are really into it, they have backup generators and things like that. But I just want to show you that the oscillator in the Collins does drift. You saw it go up, then back down, and then if you leave this stabilized, you'll see it go up and down a little bit. But you can really go off on a wild goose chase. You can go down a rabbit hole. It's a whole hobby in itself, creating a VFO that's incredibly accurate, stable, frequency on, and that. And you don't need a lot of the things that are in a Collins PTO, because we have digital frequency readouts. See, the whole idea of the Collins with the piston in there, with the ferrite piston, is it's linear, and you can calibrate it in such a way that it corresponds to one of these dials. And you don't need this is the frequency readout. You turn the dial to a certain frequency, that's the frequency. And here's the fine adjust, where you can see, am I in the frame? Yeah, you can see the fine frequency down to so many hertz. But we use frequency counters, and I'm telling you, where do you draw the line? Do you pick on the old set that was designed, it was incredible in its day, versus a modern one? Or do you compare the modern one to a cell phone? And that's what you do to people when they start, oh, those old sets drift a lot. Well, we don't need your new set. We can go use a cell phone. And the price per minute now to talk to somebody, if you got a plan, it's nothing. In the old days, you could talk to a cousin in another state and sit on there and talk back and forth. It didn't cost you any money versus a telephone. But now with the cell phone plans, you can call the person up anytime, no matter where they are, and basically talk to them for free. But I just wanted to show you, stuff does drift, and even the frequency counter, sometimes the frequency doesn't get in through the gate at the right moment. So you'll see this thing jump up a few digits instead of one at a time. But I put a lot of time into this. What's the best oscillator? As far as making it easily made, if you go look at different projects, they really use a lot of parts in a Franklin oscillator. Put in Franklin oscillator VFO, and you'll see guys use all kinds of NPO capacitors and all that. I didn't do that. I built a straight Franklin oscillator circuit, and I have a capacitor directly across the toroid. Now the toroid coil, remember I told you it's a T50-6, and it basically has temperature stability based on for expanding and contracting the material it's made out of. And other people use other kinds of coils, and they're telling you got to get a special ceramic coil form, and it's a rabbit hole. You can go off on a wild goose chase, and the person's article that you're reading, how good is that guy? How much of it is he an experimenter or is he an engineer? What's his credentials? He built this thing, he submitted the circuit to the magazine, and they published it. And he just happens to have a bunch of surplus parts that you're not going to be able to locate. And that's why when I got in, I wrote a couple articles for magazines. I was really pissed at the fact that the guys were starting to build projects that always needed one part that you had to buy through them. And I talked to those guys. I talked to Don Lancaster, actually Lancaster, right? We say Lancaster out here. But Don Lancaster, you could call him up and talk to my phone. He passed away last year. And he said to me, he goes, that's how those guys make some money. He says, you only get a couple $100 for the article. And then by selling the part, out of the back of the magazine, the person buys the part, they might buy the circuit board from you. You send them a brochure of other things you had, and that's what Don Lancaster was doing. In other words, you build a little empire and be a writer at the same time, because there's no real money in writing technical stuff. You only get paid per article. They don't put you on salary. I won't go all through that. That was one of the things I went through. I think that's it. All right, that's it.